In 2011, the California Air Resources Board, otherwise known as CARB, published an urban forest protocol that closely outlined how to quantify and report greenhouse gas emission reductions associated with carbon storage in trees. Qualifying projects are eligible to receive cap-and-trade funding for the estimated amount of carbon dioxide offset by regional trees.
To encourage participation in this program, the Sacramento Tree Foundation hired a Bay Area-based think tank, Spatial Informatics Group, or SIG, to develop an analytical approach to tracking urban forest carbon storage and to quantify additional environmental service benefits. SIG combined field-based measurements with LiDAR data to create an inventory of over 3.6 million trees from 17 municipalities in the Sacramento region. The resulting database could potentially be used by utility companies, educational campuses, and municipalities to validate greenhouse gas reductions.
To expand upon the work already completed by SIG, 3 key questions were targeted for our analysis. First, what is the distribution of tree carbon storage by parcel in the Sacramento region? Second, does this distribution shed light on any social justice inequalities? And third, what impact does maintenance vehicle and equipment choice have on total project greenhouse gas reductions in the region?
To answer these questions, the group began by confirming the tree carbon storage values calculated by SIG for tree points in the region. The tree point data was then spatially joined to the parcel data for the area of interest to produce the sum of all carbon stored in each parcel. This map was created using the tree data to calculate the sum of each parcel's total carbon storage. The warmer colors represent drastically less carbon storage per parcel, as the blue tones represent a large amount of carbon storage per parcel.
Now that we understand where tree carbon storage is occurring, we can identify areas where additional tree planting efforts should be concentrated by comparing the data to environmental justice areas. Environmental justice areas are designated by Cal EPA based on regional environmental pollution, public health, quality of life, and economic opportunity. Focusing future reduction efforts around disadvantaged communities aligns with the governor's goal of investing proceeds from California's cap-and-trade program back into the state's most burdened communities to reduce the pollution that causes climate change.
Comparing the carbon storage map to the map of environmental justice areas, utilizing Cal EPA's designations based on CES 2.0 scores, the relationship between the two maps becomes evident. Now let's look at another area with low carbon storage values and compare it to its CES 2.0 scores. Again, this area of lower carbon storage has a CES 2.0 score above 50%, which tells us that this area is in a more disadvantaged region. To investigate this trend further, we took a look at the same data and visualized it graphically. As you can see, most of the areas with lower CES 2.0 scores have an on average higher carbon storage levels than the areas with higher scores. Carbon levels of areas with CES 2.0 scores in the upper 50% are all less than the average carbon storage level. And lastly, combined, the parcels with the CES scores below 50% have more than twice the amount of carbon storage from trees than the combined parcels with scores above 50%. The third and final question was to determine the project greenhouse gas reductions over the 25-year timeline specified in CARB's Urban Forest Protocol. To calculate project GHG reductions, maintenance vehicle and equipment CO2 emissions were subtracted from the total carbon for the area of interest. 2 scenarios were used: business as usual and the conversion to a green electric fleet. The green electric fleet scenario reduced CO2 emissions by an average of 67% over the project lifetime, with an estimated value of over $480,000, and equivalent to planting over 17,000 new trees in the region. In conclusion, it is our recommendation that the vast benefits of Sacramento's urban forests are applied holistically to the region by concentrating future planting efforts in environmental justice areas, and that electric vehicle and equipment technology is utilized to maintain urban trees.